All right. So we've already been introduced kind of to what statistics is, right? And I kind of want to formalize that through what we call data, because the big part of statistics is data. How do we analyze the data? How do we gather the data? How do we summarize the data? And technically, the definition of statistics is actually the science of collecting, analyzing, summarizing, and inferring from data. All right. So we collect the data, we analyze the data, or we summarize the data, right? Technically, it's organizing. So we organize the data. And by organizing, that means you're going to put it into a nice little graph or a nice little picture for somebody or a nice little table. And then from there, you're going to summarize that data. Summarizing means you give me number values. Start to give me those things like, you know, remember when I did it with y'all, I collected data in that dot plot, right? And then I organized the data, or I collected that data from y'all by letting y'all read, and y'all gave me data. Then we organized the data by looking at the dot plot. And then from the dot plot, we were able to get summary value, summary statistics about it. And then the last step is to infer about it. And when you infer, you're inferring from what you see. Inferring just means to guess what you did. You tried to guess the true number, right? So when we start here, we're going to talk about types of data. This is important. When you talk about types of data, there are two types of data that you got in statistics. All right. That is what we call categorical, or you also may say it called qualitative, but categorical or qualitative data. And then there's what we call quantitative data. And if you think about, I like using the words qualitative and quantitative better, but a lot of people use categorical. But qualitative or categorical data just means that when you look at a variable, and remember, a variable is anything that changes from person, place, or thing. So we defined it back in the day. When you look at a variable, categorical variables either name, they describe, they order, or they distinguish. All right. And name, describe, and order are common things that we do with variables. And by name, I mean like if I ask you your favorite color, right? If I ask you for your favorite color, what are you going to tell me? Or you're going to say things like that could be red, or that could be blue, or that could be green. Or if I ask you to describe or order, for instance, if I ask you to order, when you order something, in this case, you mean the order, for instance, we can think of if you go see the new movie, you want to see a new movie, and you rate the new movie. When you give a rating is an ordering of something. Was that movie, did you find it poor? Did you find it average? Did you find it good or did you find it great? You buy something from Amazon, was it 1 star? Was it 2 stars, 3 stars, 4 stars, or 5 stars? Those are what we call ordering variables. You can also order variables about actually for your classification, for instance. Are you a freshman? Are you a sophomore? Are you a junior? Are you a senior? Those are ordering variables, but they're all categorical. They put you into categories. And then the trickiest one is what we call the distinguishing variable. All right. And when you distinguish something, it generally comes in a number form. And I say that because if you go to the next part over here, qualitative variables, qualitative, the word, or quantitative variables, I'm sorry, the word quantitative has the word quantity in it, and it means it's some kind of number. So typically speaking, we're thinking of numbers when we talk about quantitative data. And when we talk about numbers, numbers can do one of two things for me. So either the number, and I want you to understand the difference between the two. Numbers can either count or they can measure. Can anybody tell me the difference between counting and measuring? Does anybody know what the difference is between those two things, counting and measuring? Or do you think they're the same things? For instance, do you
Count
count? Go ahead, I'm listening. Go ahead.
counting.
Go.
Counting would be more than one thing, and a measurement is a measurement of one thing.
Okay, that's a good guess. That's close. Let's talk about this. If I
Counting
ask
is
you for your height, go ahead. I'm going. Keep going. You can go.
yeah. That I was gonna say like counting when you count like a group of things and then measure like you measure like the length of something.
So basically, you like y'all are saying that counting is a more
Like
than one thing
counting
type
individual
activity,
things. Yes.
right? Counting is more than one thing. Where measuring is just a single thing that you're doing that you're trying to count that single thing, I guess, right? Let me ask you a question.
Yes, like the
If I
length
ask
or
you
something.
if I ask you to count your height, what would you tell me your height is counted?
In
We,
inches or feet.
So you would, but if I ask you to count your height, give me your count your height in inches. What would you tell me that is? Anybody? Count your height in inches. What would you tell me that is?
72 inches.
Are you really counting your height though? Better question
No,
is this. So
you're
you're
measuring
70,
it.
70,
You're measuring
if
it.
you're 70, good, you're measuring. So if you're 72 inches though, how tall are you really? How tall is that? That's 6 foot
6'1". No,
six
that's
one.
12.
Okay. 6'2". 6'2".
6'2", yeah.
Yeah, 6'2", because 55 feet is, I got you. So let's say you're let's say you tell me that you're 6'2", right? Because you've counted your height to be
Uh-huh.
6'2". Are you really 6'2" though? Like, maybe
Yeah.
could you be
I mean, I
6'2"?
am.
Could you? But you're exactly 6'2". Could you be 6'2" and a quarter of an inch?
Oh, yeah.
Or could you be 6'2" and an eighth of an inch and be more precise? Because that's more precise. Or could you be 6'2" and 3/8 of an inch? Or maybe you're 6'2" and 5/16 of an inch. Or maybe you're 6'2" and 7/32 of an inch. Or maybe you're 6'2" and what, 17/64 of an inch. You see what I keep doing there?
Yeah.
You told me you're 6'2", and you're telling me you're 6'2" because the device you use to measure yourself only measures in a certain amount of inches. Does everybody understand that? But if I got a
Yes.
different device, I could measure and you'd be more exact, right?
Uh-huh.
So the problem with measuring is this though. We're limited to measure things in terms of whatever device we're using to measure it with, which means that if I have a better device, I can always get better and better with my measurement. As opposed to when I count something, if I ask you to count the number of F's, what had to be true about the number of F's? The number of F's always had to be a what?
A whole
A
number.
whole
A
number.
whole number. They have to be whole numbers. Is there any is there any is there any misunderstanding of what an F is? It's either a F, it's either a whole number or it's not a whole number. Everybody got, it's either a whole number or it's not. It's either F or it's not. So when we count, and here's the difference between counting and measuring. Counting is always a whole number. It's always a whole number. And when we count, we go from 1, 2, 3, 4, 5. We count. We always end up with a whole number. Measuring though, measuring comes in the forms of, measuring can be fractions. They can be parts. And so because of that, we have two different types of counting variables. If a number count, or two different types of number variables, quantitative variables. If a number counts, which means if it gives me a whole number, such as when I ask you to find the number of F's, you're dealing with what's called a discrete variable. It's called discrete. Does anybody know what discrete really means in math? Like if you're in a, let's use it in English. If you're in a discrete relationship, what does that mean?
Like
Anybody?
a secret.
Yeah, it's like a secret. It's like you're isolated. In
What's
terms of math, what it
exclusive?
really, in terms of math, what it really means is that you're isolated on the number line, or you're isolated at a point. You have to be at a value, which means you have to be at a whole number on the number line. That's what discrete means, as opposed to a continuous distribution. Continuous distributions go on forever. And what I mean by that is, in order to capture a continuous value, you have to give it a range. So instead of saying you're 6'2", I may say you're in between 6 feet and 7 feet. And I've captured you in a range. I have to put you inside of a range to capture you. And generally speaking, anything that you attach a unit of measurement to is continuous. For instance, when I ask you how tall you are, you'll tell me you're 6 feet 2 inches. That is units of measurement. If I ask you how much you weigh, you may tell me you're 150 pounds. That is a unit of measurement. When you put the unit of measurement on the back, it is a continuous variable. Does everybody understand that? When I put a unit of measurement on the back, it is a continuous variable. So here's another example. If I ask you how old you are, the variable old, let's say somebody is 20 years old. Is that a continuous variable or is it a discrete variable? Is it a countable variable or is it a measurable variable?
Measurable.
Everybody agree?
Yes.
I don't think you count your age. 20 is a whole number, right?
Yeah, but you
Right, but you could be
can't you
20
be
in
20 and
months.
2 months? Yeah.
Yeah.
Good job, good job, good job. And also, if I get confused, how old am I? I'm 20 years old. What am I putting on the back of that? A unit of
Years.
measurement, right? A unit of measurement. Years is the unit of measurement. So look, here's what happens then. Variables can either count or they can measure. If they don't count or measure, they do what we call distinguishing. And by distinguishing, I mean this. If I ask you what is your phone number, your phone number, your phone number is a what? It's a number, right?
Yes, discrete.
Good. But does my so let me ask you a question. Does my phone number count me?
No, it distinguishes you.
Good. It distinguishes you. It doesn't count you and it doesn't measure you. It distinguishes who you are. So actually your phone number is a categorical variable. So I'm going to give you a couple variables here and I want you to tell me what they are based on what you know. So let's say we take a survey and I ask you, what is your major? If I ask you, what is your major? What kind of variables? What is your major? What do you think you would give me?
Categorical.
It would be categorical. You would give me categories. You would say business. You may say, what else? Education. You may say philosophy. You may say something like that. All right. So this is a categorical variable. That's categorical,
Yes.
right? Now, what is your classification? When I ask you about classification, I mean, are you a freshman?
Categorical again.
Are you a sophomore? Sophomore. Are you a junior? Are you a senior? What kind of variable is this?
Categorical again.
Categorical. And they're ordering, by the way. This is a categorical variable that orders. This is the ordering variable. How much sleep did you get last night? What are you going to tell me? How much sleep? I may have got, last night I think I may have gotten 3.5 hours of sleep. So I may have gotten 3.5 hours of sleep. Because I'm attaching the unit hours, what does that tell me?
It's continuous.
It's continuous.
Quantitative,
Good.
yeah.
This means that so this is a it's a quantitative variable first, right?
Yes.
But because we attach the unit, that means it's a
Continuous
variable.
numerical.
Good.
And if you did this thing, I got a good amount of sleep, it comes in the first category, right?
If somebody said it like that, yes. And somebody might say it like that. Technically, a good amount of sleep, yeah, that would be categorical. Do you have any children? First question, do you have any children? How would you answer that? How would you answer this question right here? Do you have any children?
With a whole number, because you can't have a partial case.
Try it again. Do you have any
It'd
children?
be yes
As
or
a
no.
yes or
No.
no.
Yes or no.
Yes
So this
or
would
no.
be good.
Categorical.
This would be good. This is yes
Quantitative.
or no. So this is categorical. This first part is categorical. Now the second part of the question though, if so, how many is what?
A discrete numerical.
Discrete numerical.
Why is it discrete?
Because you can't have a half child.
Good. It has to be a whole number. So this second part is a discrete variable. Can't see that. This is discrete. How many letters are in your first and last name combined? What is that going to be?
A discrete numerical.
Why is it discrete?
Because there is a certain amount of number of letters in your name. You can't have like a half letter.
How many? This part right here says how many letters. That means I'm asking you to count those letters. I want you to count it. It has to be a whole number when you count.
So it's quantitative and it's discrete, right?
It's quantitative. If I'm sorry, I'm not writing quantitative. If I write discrete, I want you to know that means it's quantitative though. You're right. That is quantitative. But it's quantitative discrete. If I say discrete automatically assumes that you're talking about a quantitative variable, by the way. Favorite day of the week?
Categorical.
This is a categorical variable. Monday, Tuesday, Wednesday, all those days, categorical variables, right?
Yep.
How tall are you? You may tell me that you are 6 feet, 2 inches, right? You may tell me that you are 5 feet, 4 inches. How tall are you then? You may tell me that you are 60 inches.
Continuous.
So that means that what kind of variable? This is a continuous variable, which means that it is a quantitative variable, right? All right. Do you wear glasses, contacts, or neither? What is that?
Categorical.
Categorical.
That is categorical. Good. That is a categorical variable. Glasses, contacts, or neither. You're falling into a category. How would you rate, this was last year, how would you rate 2020? How would you rate 2021 thus far? And now you're on a rating scale. I'm gonna ask you to rate it on a rating scale. How would you rate it?
Discrete.
Quantitative.
This
So y'all
Great.
want to call that
That is
quantitative, right?
categorical. Because
This
it's
is
an order.
categorical. Good. This is
It
categorical.
could be it could be continuous depending on the scale.
Well, let's talk about that. Can it be continuous?
Out of 1
What
out
do
of
numbers
10.
do again? What do numbers do again?
Well,
Numbers
the
do one of they,
continuous is a measure, right?
right, but what do they do though? You're not measuring something right here, by the way. Measuring means
Oh,
something.
you're rating it. Oh, okay.
You're rating it, and I want you to understand that a rating is not a measurement. A rating is how you feel about
Yeah,
it.
like from bad to good. Yeah.
But what
Yeah,
if the
you can
rating
think of
is
it
like
like that.
of 1 to 10?
Even if you go from 1 to 10, it's still, what are the numbers doing? Let me ask you a question. When I measure when I measure something from 1 to 10
You're
on the rating
saying
scale,
one is bad and 10 is good, like
you're,
that, right?
you're saying, yes, you're saying how you feel about it. Are you
sense.
are you physically measuring something from 1 to 10?
No.
Are you measuring the distance from 1 to 10? No. That's how I
No,
need
it's
you to
your
think about this.
opinion.
Yeah,
Oh,
it's
you
an
just
opinion. I
fall
want you to
into a
understand that.
category of
Right.
the rating.
So these are all categorical. Anytime you see a rating scale like this is always going to be categorical, all right? It'll always be categorical. What is your anticipated year of graduation? This was tough, by the
Categorical.
way. Why is it categorical? That's the right answer.
Because you're not counting it like the other slide. You're just
And you can think
falling
of it
into a
about
category.
good. If you graduate in 2024, right? Versus you graduate in 2026, am I trying to measure that? Am I measuring something there? Because you would think with the word, what is your year? You're not measuring your year. You're actually telling me the category which you fall into. All right. And this is difficult right here because I see the unit of measurement year here, right? But I also know that that unit is not measuring, it's not actually physically measuring anything. It's just telling me it's a category, or you can think of like a bin or a basket or a cup that you're trying to put people into to organize them as a group. Technically, this is a distinguishing variable. This distinguishes. This is what I mean by distinguish. Distinguish tells you you're in a different group. All right. So this is categorical. What do you do for a living?
Categorical.
Categorical. Roughly, how many miles do you have on your primary vehicle that you drive? How many miles do you have? What do you think that is? How many tells me it's going to be some
Quantitative.
kind of quantitative variable. Now, quantitative, is it discrete or continuous?
Continuous.
Discrete.
Continuous.
Continuous.
Because
could
you
have
have the point
Miles.
1, 2, 3, 4.
Thank you. You think of your own speedometer, you would see point something on it. Also, the key thing is you're talking about miles. And how many miles at this unit of measurement? You're going to tell me you may have 60,000 miles in your car right now. So this is continuous, right? What is your resting pulse rate? What is that one going to be? Resting pulse rate.
Categorical.
Discrete because you counted it.
So let's talk about pulse rate. Pulse rate.
It's a measure of your pulse, though. So wouldn't it be
It's a measure.
quantitative?
So that is definitely going to be quantitative. That's going to be quantitative. Now, when you measure, since you just said you measured it, what kind of variable does that be?
It would be continuous because it's your beats per minute.
Right, definitely continuous. Good. Continuous. All right. go to the next one. Do you identify as male? Yeah, do you identify as male or female? What's that going to be?
Categorical.
Categorical.
Good. So that's a categorical variable. So do we understand the difference between categorical and quantitative variables?
Yes.
Sir.
Yes.
All right, good. We understand that, right? Now, other things, do we understand the difference between discrete and continuous variables?
Yeah.
Yes.
Yes.
All right, good. So last thing I want to talk about real quick then is the ways we gather data, ways to gather data. Because one part of statistics is how do we gather data? We need to gather that data. And there are primarily three ways in which we gather data. They are through surveys, observational studies, and experiments. All right. And a survey is a specific set of questions that are designed to gather information from a population through a sample. So we take a sample and we try to gather information about a population. We'll get into that in a second, what those are. But it's a specific set of questions that are designed to gather information. In an observational study, we typically, the researcher wants to observe some phenomenon and make a hypothesis about that. But the researcher has no control over what's taking place. They're just observing. That's why it's called the observational study. So they'll look at data and they'll look at the things that are taking place and they'll try to they'll try to verify hypotheses based off of that, all right? That's an observational study. In an experiment, the researcher has direct control over variables that are to be manipulated. So the researcher can actually change how the variable moves up and down, right? That's what they can do. And in an experiment, the goal of an experiment is to develop this right here. We call it causal relationship. And the word causal means that you're trying to develop a cause and effect relationship between two variables. The only way we can develop a cause and effect relationship between two variables is through a controlled experiment. Experiments are the most powerful ways to gather data. All right. And they're also the most technical way to do it too. So we use the other methods because they're simpler, they're cheaper, they require less resources. But experiments are the only way to develop cause and effect relationships. And so like when you look at things like right now in real life, like for instance with COVID, it's really hard to do COVID experiments. In the beginning, it was very hard to do COVID experiments because here's what happens. In an experiment, you have to have one group is going to subject, both groups are going to subject themselves to the virus. One group gets a supposed treatment, the other group gets a placebo treatment. And you look at who survives the virus and who doesn't. Well, in the beginning, what they saw was when they gave the vaccine to people, it prevented those people from getting the virus and it didn't kill them. As opposed to the people who didn't get it, they were catching it at a much higher and much more alarming rate. And so what ended up happening was when they start the study, you want to do it over a long period of time. You want to start the experiment, do it over a long period of time. Well, the problem is you have all these people dying and all these other people being saved. So it became an ethical issue where we can't do an experiment to do this. So with these vaccine studies, what happened was a lot of the studies got shut down quick. And that's why it was like really hard to actually see if the vaccine worked or not. All right. And that's because in an experiment, we have to control things. And typically speaking, we have a group that we give the placebo, we give them something where they're not going to get the actual thing that's taking place. So it's really hard to actually do that ethically to some type of things. All right. So keep that in mind. Would you say that people who smoke tend to get do you think people who smoke tend to get lung cancer? Yes or no? True or false? True or false? People who smoke tend to get lung cancer. Yes or no? True or false?
True.
True. Okay. Would you say that overall the smoking causes lung cancer? Yes or no? Smoking causes lung cancer. Yes or no?
False.
Why?
Some people don't smoke and they still get lung cancer.
Good job. Great way to come at that. So I want you to understand this. If we say something causes something else, that means that every time this occurs, then what should happen? That effect should always occur, right? And you see a lot of people, one of the basic things people tell you is that smoking causes lung cancer. Well, in order to actually test that theory, how would we create an experiment to test that theory? We would subject some particular humans to
To
smoking, even
smoke,
the ones that
yeah.
don't smoke, right? We would make them smoke, and it would see what we would see over a long period of time. They cause lung cancer from it. Well, that's not ethical. So those experiments had never been ran. They have always been observational studies where we observe that there tends to be a high correlation between smoking and lung cancer. You
But you
got
still
that?
could
There
do
tends to
it
be a
anyway.
very high.
You can't
Yeah, you could.
control all the other variables.
Right, but we can try to, and that's a good point. We can try those other variables, or call what we call confounding variables, by the way. And the goal of an experiment is to try to control those confounding variables as much as possible. For instance, one particular variable that may affect lung cancer and smoking may be age. So I'm not going to look at young and old people together. I'm going to look at maybe a particular age group. Another variable could be gender. So I'm not going to look at males and females. I may look at only males in a specific thing. So we can try to control them as best we can. But you're right, we can't control all of them. And if we can't control them, they're called confounding. And confounding means that we don't know if, for instance, we don't know if age is the factor that causes lung cancer. We don't know if gender is a factor that causes lung cancer, if we don't control for it. But experiments are highly technical, and they're the ones that we can show cause and effect with. All right. So real quick, in the survey, I told you that we take a population, and from that population, we draw a sample. The goal is to, from the sample, use that to infer about the population. All right. The population is the entire collection of interests. It is what I like to call the big picture. When I talk about a population, I'm talking about the big picture. And the sample is what I like to call the details in that picture. Depending on what you sample, they'll tell you what you're going to see. If you take a well-representative sample, then you're probably going to get a good idea of the big picture. If you take a very focused and narrow sample, it's going to be biased and you won't get a very good idea of the big picture. I got that? So typically, when we take our samples, right, when we do that, we need to make sure that we want our population needs to be representative of the entire subset. All right. So the population itself is what we're trying to do with the population is there is some true value within the population. We call the true value the parameter. This is what we call our true value. And what I mean by that is, for instance, when we did our activity a second ago, your population was the entire paragraph that you had. I got that? And there was a true value of F's on that page that you were trying to count. Does everybody understand that? You were trying to count the true value. The problem is most of y'all couldn't count that. And everything that you gave me was a statistic. And a statistic is basically this is an estimate. It's an estimate of the true value. It's an estimate of the true value. And what I want to do is I want this estimate to be an accurate reflection of the true value. And that true value or that parameter comes from the population. Population P, parameter P. The sample holds a statistic. The sample gives us a statistic. Sample F, statistic X. They belong together. So when I look at a value such as, if you told me that the value was 32, 32 is a statistic. 50 was a statistic. They were values that were estimated from the sample. Got that? On the other hand, the true value, the parameter value there was 47. Now, even you people that gave me the number 47, you were giving me a statistic because you were giving me a guess. You did not know that was the true value. It just so happens that your true value or your guess was the same thing as the actual true value. Your statistic equal your parameter. We take samples because samples require less resources. And what I mean by that is we take samples because one resource we're always focused on is money. Another resource we're focused on is time. Samples take less time than looking at an entire population. By the way, if we sampled the entire population, If we sample the entire population, it is called a census. How often do we do a census? Anybody know?
Every 10 years.
The one.
Every 10 years. Why every 10 years? Why not every year?
And let people
Why not every,
die and be born.
okay, but still, why we could still count people
Because they
dying and
pay
born.
people to also take
That's
it.
one reason.
So
The
If you
repetitive.
don't know how to take it, yeah. If you don't, but if you don't know how to take a census, when they take a census, people go door to door and knock on your door to door, to count you.
It's too
You got to pay those
resource
people.
intensive to do every year.
There you go. It's resource intensive. I want you to understand that. We take censuses because we take census every 10 years because the amount of resources they require. All right. It's again, it's you can sample the entire population, it's called a census, but when you do it like that, you're gonna have to suffer. Some things are gonna suffer. So that's why we take it every 10 years. All right. But generally speaking, a sample is the smaller thing, the smaller subset of the population. The population is the big thing. It's the actual, it holds the true value of the parameter. So let's look at these examples. For each of the following, identify if the underlying value is a parameter or a statistic. So you're going to see the value is underlined. I want to know, is it the parameter, the true value, or is it a statistic, the estimate of the population? It says, of all US kindergarten teachers, 32% say that knowing the alphabet is an essential skill. That 32%, is that a parameter or is that a statistic? I want you to ask yourself this. I want you to ask yourself this question. Did it come from a sample or did it come from a population? Is it from everybody or is it from a subset?
Statistic.
Let's look at it. What does it say? Of all of what? Of
US
all
kindergarten.
US. So all though, all of them, right? 32% say what? That knowing the alphabet is an essential skill. So because I'm talking about all, this tells me I'm talking, is that the population or is it the sample?
Population.
That is the population. Anytime you talk about all, it's the entire collection. That's everybody, every kindergarten teacher. When they sampled when they looked at every kindergarten teacher, 32% say that knowing that alphabet is essential skill. So I mean 32% is the what?
Parameter.
That is the parameter. That is a parameter. That is a parameter. All right. Next one. Of the 800 US kindergarten teachers polled, 34% said knowing the alphabet is essentially skill. So look, they're telling me how many I have now.
800.
Do you think that's all the do you think that's all of the US kindergarten teachers?
No, that's a
No, right?
sample.
No, that's just a
It's
sample.
a sample. So this is a sample. And of that sample, they tell me 34%. What does that 34% represent then?
A statistic.
That is a statistic. All right. So I have a sample, which has a statistic, or I have a parameter, which has the population. The population which has a parameter. A recent survey by the alumni of a major university indicated the average salary of 10,000 of its 300,000 graduates was $125,000. A whole lot of numbers here, but I'm only focused on the one that's underlined, which is this one right here at 300,000. Question.
That's a sample.
It says the average salary of 10,000, right? This 10,000 is only, that 10,000 only part of the population, right? That makes this the sample. And this other one is what? This 300,000 is
the population.
That is the population. This is the population. So that makes, what is the 10,000 going to be? This 10,000 is the what?
Statistic.
Statistic, where the 300,000 is the parameter. Right? That's a parameter. See, I see the difference, right? And notice this, the sample should always be smaller than the population to begin with. I got that?
Wait, so I have a question. The 125,000, that's not the statistic?
Uh-uh.
Oh, okay.
That's not anything I'm worried about. Technically, you're right. It is a statistic. It's just a different statistic of what we're talking about. We're talking about samples from the statistic, but it could be one. This is just one particular thing from it, but you're right, yeah. We already did that. We just said that this one was the sample, right?
Yeah.
Same problem, and just underline different things. That's the statistic. All right. Last thing, identify the requested values. Of the US adult population, 36% has an allergy. A sample of 1,200 randomly selected adults resulted in 33.2% reporting an allergy. What is the population here? What is the entire collection of interests? It literally says it on there. What does it tell you the population is here?
The adult population.
Thank you. The US adult population. So who is the population? This would be the
US adult.
US adult population. US adult population. Looking like that. 36% has an allergy. A sample of 12,000 random. What is the sample then?
12,000.
1,200, my fault. 1,200 there.
Oh, yeah.
Right. Identify the statistic and give its value. What is my statistic here? It says a sample of 1,200 randomly selected adults. Remember, the statistic comes from the sample, right? So
Yep.
1,200, what was their value that they reported?
33%.
2%.
So this 33.2 is the statistic. The 33.2% is the statistic. And then it says identify the parameter. Remember, the parameter comes from where?
The population.
The population, right?
So it is 36.
Yeah, so we're gonna identify the population. So the parameter here is at 36%. Good. One more. Last one. Last one. Decide the following is a survey, observational study, or an experiment. So we're gonna decide between the three real quick. There's only two examples, so one is gonna get left out. Doctors know that they can get sick from their patients, but when they're sick themselves, do they stay away from their patients? Researchers asked 537 doctors in training to anonymously report whether they had worked while sick during the past year. The researchers found that 58% said they had worked once while sick and 31% said they had worked more than once while sick. Is this a survey, observational study, or an experiment? Easiest
Survey.
question is it good? It's a survey. Easiest question is an experiment. Always start with an experiment first. Here, when you talk about an experiment, experiments are easy to distinguish because there has to be some kind of manipulation or control of variables taking place. All right. And we can see here that we're not controlling anything. We're just observing some things. And actually, we're gathering that information from people. So this is a survey. We've gathered information. Researchers asked 537 doctors in training. Right? This 537, by the way, what is that called again? That represents the what?
Sample.
Sample.
Good. That's the sample. Which makes this 58%. What second would it be called?
Statistic.
That is a statistic. Good. Good job. All right, example 2, last one. Researchers have found that among patients with colds, those who gave their doctors perfect scores on a questionnaire measuring empathy had colds that did not last as long and were less severe. Empathy on the part of the doctors included making patients feel at ease, listening to their concerns, and showing compassion. A total of 350 subjects who were experiencing the onset of the cold were randomly assigned to one of three groups: no doctor-patient interaction, standard interaction, and enhanced interaction. Only subjects in the third group saw doctors who had been coached on being empathetic. So is this a survey, observational study, or experiment?
Experiment.
Experiment. There's direct control. Good. There's direct control taking place between subjects and researchers. We are actually putting people into groups. And when we look at experiments, one key thing about an experiment, most experiments always have something where you randomly assign people. And we randomly assign people for a couple reasons. The main reason is to spread out bias between human subjects. Because you are all biased as people, and because I cannot remove your bias, I have to spread it out. But that is essentially, man. Hey, good night tonight. Thank y'all for hanging in there with me. I know it was tough. Trust me, it's tough on me. But I appreciate y'all.
Thank you.
I want y'all to have a good night. Y'all, I'm listening. Go ahead.
On the, so we have to take the survey or the syllabus test before we can get access through Blackboard on our Pearson stuff, right?
It's supposed to, but I mean, I'm not gonna restrict access. But read. It's just saying that you read the syllabus. That's all it is. All
Okay.
it literally is a true or false question. It's not really a quiz.
Okay.
It's just saying that you read it. Yeah, and it's actually making sure you have to take that syllabus quiz in lockdown though, because I need to know that you know how to install lockdown. You know how to use it already, right?
Right.
So do it in lockdown. Anybody else
Where
have a
is
question?
that survey? Because I never saw it.
What survey? The one we're talking about right now?
Yeah.
That's not a survey. It's
It's
a
a-
quiz.
Oh,
It's
a
on the
quiz.
site.
Where's the quiz?
It's on the
So
left
don't
side
worry.
under the course learning
Yeah.
resources.